Hey students, the focus for this short video is all about the concept of what is a mechanism. Mechanisms are really important when it comes to all things automation and specifically robotics. You cannot have a functioning robot without a mechanism. In the lessons that you'll be watching via video tutorial this week, you're going to be learning about 3 key learning targets. Our 3 learning targets are: I can understand energy and the use of a mechanism to transfer energy. I can recognize how mechanisms change energy by transferring direction, speed, type of movement, and force or torque. And finally, I can understand gear ratios and can solve problems using gear ratios. So really, in a nutshell, for our lessons this week, we're going to be applying science and math concepts in a real-world environment. So by definition, a mechanism is going to be a part of a machine that contains 2 or more moving parts performing a complete motion. It's so important that you understand a mechanism is always going to have 2 moving parts minimum, and that the mechanism is going to perform a complete motion, not a partial motion, not one moving part, but the 2 moving parts work together to perform one motion. So let's look at mechanisms in the form of GIFs. In the lower left corner of your screen, you'll see that we have 2 gears. Hopefully you can tell that they are appearing to look like they're meshing together, and as the one gear moves on the bottom, it is causing the top gear to rotate as well. This mechanism is called a bevel gear, and bevel gears are really important when it comes to so many robots. You probably, if you look around your house, will find an application of a bevel gear. Another common mechanism used is the lead screw. The lead screw is in this mechanism in the lower right corner. This is called a vise. You may not have a vise around your house, but you may have a smaller version of a vise called a C-clamp. They are both lead screws. You'll see on the mechanism in the lower corner, we have a handle that is rotating around, and as that handle rotates around, the black rectangle slides towards the other black rectangle. This mechanism is really powerful. I would not ever recommend putting your finger inside the clamp of a vise or a C-clamp. Another very, very common mechanism is the crank and slider. The crank and slider is found inside every single car and truck engine. The crank and slider is actually a piston. This is a picture of a cutaway of a piston from inside an engine. You'll see that the piston is that square piece reciprocating back and forth, causing the crankshaft to rotate around in a circle. If you have a 4-cylinder vehicle in your family, you have a vehicle with 4 pistons. If you have a larger truck, you might have an 8-cylinder vehicle, so you have 8 pistons inside that vehicle. Another common mechanism found in all vehicles is that universal joint, that really mesmerizing GIF that just showed up on the screen. In a universal joint, you are allowed to transfer the energy from your engine down through the universal joint and into the tire of your vehicle. The awesome part about the universal joint is it allows us to take that rotating motion and have our vehicle travel over rough ground in a slightly smoother fashion. Darth Vader in the bottom center is riding on a carousel or a merry-go-round. And in that carousel example, you can't actually see the mechanism working, but typically on a carousel, if you're sitting on the horse and you look up above your head, you will see a crank and slider. The carousel has its horses reciprocate up and down using many, many, many crank and sliders. Another mechanism that we can see in a GIF and is also found in a vehicle is that new GIF that just popped up on this screen. There's that egg-shaped cam that's rotating around, and then you have that red rectangular follower moving up and down. This mechanism is called a cam and follower. If you have a vehicle with a piston inside it, you will have 2 cam and followers for each and every piston that is in a vehicle. The purpose of the cam and follower inside an engine is to allow for gas to enter the cylinder chamber, and then after the spark plug has ignited, the other lifter opens, or the other cam and follower opens, and the gas exhausts out of the exhaust. In our final GIF that we'll see up on the screen, our final example of a mechanism is really a metronome. You'll see that the green gear is rotating around in a circle, and that pink, long, narrow rectangle has a pivot point causing oscillating movement. Metronomes are used by musicians to help them keep time. Now some work for you. Your assignment or task for today is to find some examples of mechanisms around your home, and then to find some examples of non-mechanisms around your home. I want you to use the camera on your Chromebook, or if you have the Schoology app on your phone, I want you to take some pictures of some mechanisms and post them to a media album on Schoology. And then I want you to take some photographs of some non-mechanisms that you will find around your home and post those to a separate media album on Schoology.